test. Okay, practice test number, okay, that's a number 3. You get number 3 to get these numbers. Okay, I do the, the new part first so that, we get enough time to go over all of them. But I want to make sure we get enough time to do it. Okay, so the polar form and number 2 is the same thing that we did before. So I just check one of them because you did have this one. Okay, so this is not new, but we need it. So this is number 2. You want to write the complex numbers in the polar form. Okay, write in polar form. This is again from the previous quiz. Just check one of them to make sure you remember what we did. So I check, for example, the part B only. The part B, the z is equal to the 3, I call it z, minus a radical 3i. You want to change it to the polar form. Remember, you are going to call it x plus iy, because this is like a point on the xy coordinate. So the x is equal to 3, and the y is equal to negative radical 3. Okay, you identify the location of the point. You see the location of the point. X is positive, y is negative. So you are here. Okay, this would be important for us. When you want to pick the data, this would be, we come back to it. Now we are going to find the R. The formula for the R is what? Is x squared plus y squared. Okay, we substitute, so it's going to be 3 squared plus a negative radical 3 squared. So that's going to be equal to the 3 squared would be 9. And that radical 3 squared would be 3. So we're going to have a radical, radical 12. 12 is 4 times 3, so we can have 2 radical 3. So that's going to be R. Don't use your calculator, decimal numbers, we want exact. Okay, exact representation means just 2 radical 3 is fine. Okay, now we have to pick the data. That's the important part. So what's going to be, we go with the tangent of the data, which is going to be equal to the y over x. Okay, the y is negative radical 3, and the x is 3. So we arrive at what? We arrive at the negative radical 3 over 3. You have to pick the data, okay? It is going to be negative. If it's happened to be positive, radical 3 over 3 is a tangent of the, okay, it's a tangent of 30 degrees, okay? So if this is going to be the unit circle, okay, this is going to be the unit circle. If it's happened to be positive, that would be 30 degrees, which is going to be, okay, that's it. It's going to be pi 6. But you want it to be negative, and we already decided that it's going to be negative. It's either in the second one or the third one, but we know that it's in the third one. Okay, we already tested. So we know that we must be here. Okay, we must be here. So what is here? This is a 30 degrees, 11 pi 6, 330 degrees. Okay, so the data is going to be 11 pi 6. I should get this one, the precise one. Any question? So it depends, where you are, then you pick, different cases. So there you are. We are ready to give you the result. It's a 3 minus radical 3i is going to be equal to the R, 2 radical 3 CIS of 11 pi 6. Okay, we accept this summarizing, the notation, if you like. Any question? So keep in mind the representation, and we are going to use it over and over and over in the following questions. So that was number 2. We did this one before, and we give you one question. Any question? Now the application of this polar form. Number 3 is powers of the complex numbers. Okay, it's going to be powers of the complex numbers. I just remind you, powers of complex numbers. And we have a formula for it. Remember the Moir formula. What's the Moir formula? So if you have a complex numbers in polar form, cosine of theta plus I sine of theta all raised to the n is going to be equal to, just bring this n down here. So it's going to be equal to the cosine of the n times theta plus I sine of the n times theta. You must know this formula to be able to do this type of question of the type 3. Okay, the Moir formula. Now they may give you 2 different forms. Just a ready one. See, ready one is part 1. It's already in the polar form. So what they give you is this one. So we want to find this power. It's a 4 times. Okay, 4 times cosine. Okay, it's going to be cosine of 40. Cosine of 40 plus I sine of 40. It's a 40 degrees, okay? 40 degrees. And to the third. Sometimes they may put it inside the bracket and raise it to the third. So this means you have to raise 4 to the third and the parentheses to the third, okay? In this case, 4 is outside the parentheses, so you don't need to do anything to the 4. But be careful, if they put it inside the bracket, then you have to do something to the 4 too, but not in this case. There you are. So let me just, okay, I know I have another one because I want to make sure you know that if it's going to be bracket, see if it's going to be bracket, it's going to be 4 to the third, etc. But not in this case. So there you are. The power is 3, the Moir formula. So 3 times 40, that's going to be how you take care of these powers. So the solution is going to be, you don't have to, but I rewrite it to emphasize the problem. Okay, cosine of the 40 degrees. And this is going to be I sine of the 40 degrees. Raise it to the third. I'm not going to do anything to the 4, but it's going to be cosine of 3 times 40 is going to be 120 degrees. Okay, plus I sine of 120 degrees. Okay, by the Moir formula, you can bring the 3 down and multiply. Now you are going to simplify it for us. Okay, you know, you can use your table if you like to find these, or just do it. Cosine of 120 degrees is like the cosine of 60 degrees, but it's negative. The cosine of the 60 degrees is 1/2, so it's going to be negative 1/2. Okay, it's going to be negative 1/2 plus I times this is going to be sine of the 60 degrees, which is radical 3/2. So radical 3/2. Okay, you multiply the 4 inside. So if you multiply the 4 inside, 4 times negative 1/2 would be a negative 2. Okay, it's going to be negative 2 and plus, okay, plus this would be, we rewrite it as 4 times 1/2, that give you 2. So that give you 2 radical 3, 2 radical 3, I, the final answer. Okay, what's the question? That is going to be the case. Why 60 degrees? I didn't say 60 degrees. I take 120. 60 degrees is going to be its reflexive angle. You see cosine of 120 in the second quadrant. Okay, it's in the second quadrant, and it is like what? It's like the cosine of the 60 degrees. That's negative. You can check it from the table, but these are your interpretation. You see, that's the one. Remember reference angle? See, this is the one. This is 120. Okay, this is going to be 120. You know that this is going to be the same as this one, but different signs. The sign is going to be -1/2. That's the one. And you can check it with your, your table. This is the way we quickly take care of this. Okay, and this is the way you should be. You get yourself familiar to do this type of problem. Okay, that will help you. But the table is there. But check these would be useful. Okay, any question? So this is the final answer. This means when you bring the 3 down, you are not done. You just apply the Demoivre formula, but then you have to simplify it for us. So this, the result of the operation is nice, -2 plus 2 radical 3. Any question? That's the one we call it type 1. Is ready for you. But there is another one or another type that you have to make it ready. What is the other type? Is the second part. Second part, you want to find the radical 3 minus I to the 6. Of course, you are not going to raise it to the 6. It's not possible for you. Okay, so what we are going to do is, you see, in order to get to the Demoivre formula, you have to change it into the polar form. So you are going to take radical 3 minus I out, go, change it into the polar form, then come back. Okay, when you come back, you are going to have this type of expressions, and then we can take care of it. Okay, so take this one out. What is going to be the polar coordinate of? So we start from the here, or radical 3 minus I. I'm going to write it down like x plus I y. Okay, so my x is going to be equal to the radical 3. My y is equal to the -1. Okay, I check to see where are you. This is it. So x positive, y negative, x positive, y negative. So you are here. You know that this is very crucial to pick the correct data. Okay. So let's go and find the r first. So the r is going to be a square root of x squared that gives us 3, y squared that gives us 1. Okay, radical 3 squared would be 3, 1, so r would be 2. Okay, r is equal to 2. So pick the tangent of the data. The tan of data is y over x. Y over x would be what? Would be -1 over radical 3. You have to rationalize it. You have to multiply the top and the bottom by radical 3. It's going to be negative radical 3 over 3. Okay, you have to do this operation, then pick the angle. Again, you see radical 3 over 3, you know that radical 3 is the same one that we did. Radical 3 over 3 is going to be what? Is tangent of the 30 degrees. Tangent of the 30 degrees, but you want it to be here. In order to be here, it's going to be what? It's going to be 11 by 6, 330 degrees. Okay, so all is 360. You take out the 30 degrees, so 330 degrees, which is going to be 7 by 6, 11 by 6, 11 by 3rd. Or 11 by
11 by
6,
6, yeah.
6, yes, 6. That's going to be the one. Okay, any question? Now we go back, we are not done. So what we did is now we can write the radical 3 minus I as what? As 2 CIS of 11 by 6, then raise it to the 6. Okay, are you done with this page? I have to go to the next one to get this one done. Okay, so again, it's very important to just pick the correct data. So this is it. So radical 3 minus I is going to be 2 CIS of 11 by 6. So go back to the original question. The original question was radical 3 minus I to the 6. So expand this one. If you like, it's going to be 2 cosine of 2 times cosine of the 11 by 6. You can stay with that notation if you like, we don't mind. Plus I sine of the 11 pi 6. You see everything to the 6. That's what I was talking about. Okay, everything to the 6. So the result is going to be 2 to the 6, 2 to the 6 times. Now for this part, we are going to use the Moire formula. So we bring the 6 down, we multiply by this. So the 6 and the 6 would cancel out. Okay, it's going to be cosine of. Okay, cosine of the 11 pi. 11 pi plus I sine of 11 pi. Any question? We bring the 6 down, so it's going to be like 6 times 11 pi 6. So we simplify it, that gives us 11 pi. Okay, now we have to find it. You know that the cosine and the sine, you can forget about any multiple of pi, or because the period is what? The period is going to be 2 pi. So this is 11 pi. You can drop the 10 pi. So this is going to be like cosine of the pi. Okay, you go around the circle. So you end up with there. So this is going to be like cosine of the pi. I write it down for you so that you know they are periodic function. So this would be like cosine of the pi. You can forget about the 10 pi, 5 cycles if you like. And this is going to be plus I sine of the pi. Okay, now sine of the pi is 0. But the cosine of the pi is a -1. And 2 to the 6 is going, so it's going to be 2 to the 6 if you like. 2 to the 6 times -1. 2 to the 5th is going to be 32. 2 to the 6th is 64. So that gives you 64 times 1, -1, which is -64. Okay, so radical 3 minus I to the 6 is going to be -64. It's a very nice formula. Otherwise, you know, there is a formula that you can raise this one to the 6. I mean, but it takes quite a while to be able to do it. Okay, so this is how we would like you to do this type of problem for us. That would be, we give you one of them. It's the application of the de Moivre formula. Okay, the fact that if you do have it in the trigonometric form, okay, or the polar form, then you can bring the power down. You bring the power down, you multiply by the angle. That would enable you to simplify. This is going to be 11 pi. 11 pi, you see, it's a 10 pi plus pi. 10 pi means you go around the circle. You see, you can leave it because you know that cosine is periodic. So you can forget about the period. So that gives you pi. And this would be pi. Sine of the pi is 0, cosine of the pi is -1. So the final answer, -64. Any question? So that would cover that section that we did. Okay, so one is straightforward, the other one is you have to get it yourself. Now, the other question is operation with this polar form. Remember, we can multiply or we can divide the complex numbers in polar form. We talk about it. If you multiply two complex numbers in polar forms, you multiply their absolute values, R, okay, and then you are going to add those angles. So Z1, Z2 is R1, R2, CIS of theta 1 plus theta 2. But if you divide the Z1 by Z2, it's going to be R1 divided by R2, CIS of theta 1 minus theta 2. So when you multiply, you add the angles, and when you divide, you subtract the angles. So that's the idea that we are going to check it again. It's the idea that it's going to be checked in number 4, because again, this is an important formula. We want to make sure that you know it. So that is going to be number 4. The number 4, they ask you to find these two parts. And for the first part, so this is 4a. Two numbers are given, they ask you to multiply it. So the numbers are, okay, this is it. I just write the multiplication form and the number at the same time. They ask you to find the Z1 times the Z2. Okay, the Z1 is given to you. This is Z1. Z1 is 1/2 times just the polar form, cosine of 280 degrees plus I sine of 280. That's the polar form of the Z1. You want to multiply by, okay, multiply by Z2. What is the Z2? Z2 is 29. Okay, 29 times CIS of 50. So cosine of the 50 degrees plus I sine of the 50 degrees. Okay, this is multiplication in polar form. So this is the way we do it quickly. We multiply these two together, the numbers. So it's going to be half times 29 times 29 and the CIS of cosine of, add the angles, you see, 280 and that's 50. Okay, 280 and 50 would be 330 degrees. Okay, and this is going to be plus I sine of the 330 degrees. Okay, so this is a formula that we established it before. So we're going to use it. R1, R2, CIS of theta 1 plus theta 2. Now we have to simplify it. We simplify this to give you 19. Cosine of 330 degrees, you know that the cos 330 degrees is going to be where? It's here.
Add 3/2.
Okay, that's the one, yes. So the cosine is going to be like the cosine of the 30 degrees, which is going to be, yes, red 3/2 positive. Okay, plus I times the sine of the 330 degrees. The sine is negative, so it's going to be I times negative 1/2. Okay, any question? And you have it, on your table. You can get it from the table, but you have to simplify it and write it down as a complex numbers. Okay, so we multiply inside. So that give you radical 318. Okay, and this is going to be minus 29. 29 of, I'm sorry, this is going to be 1/1. Okay, 118. Negative 118 I. Okay, repeat it again. So this is going to be Z1 times Z2. Z1 times Z2 would be radical 318 minus 1/18 I. This gives you the final answer. Okay, sometimes if it is not going to be something nice, they give you the instruction in your book. They give you the instruction that, I said in rectangular form. They may say in polar form. If they say in polar form, that's a polar form. But we give you something that we would like to check. Okay, so it's going to be rectangular form. So this is rectangular form. Okay, no cosine, no sine. So you have to simplify it for us and give us a nice form. Okay, any question? So you have to remember that if you multiply the polar form, the complex numbers in polar form, you multiply the r's, absolute values, and the, argument, we call it, those angles. We add them together. That is the case for the multiplication. We have the case for division. When we divide, you know that we are going to find the difference of the angle. So this is going to be part B. Part B, the numbers are different. They ask you to divide the Z1 divided by Z2. Okay, now you bring the numbers. Is going to be equal to your Z1 is, over on the top is 22. It's 22 CIS of 11 pi 18. You can write it down in the CIS if you like. It's a cosine of 11 pi 18 plus I sine of 11 pi 18. Okay. You want to divide it by 11. 11 CIS of 5 pi 18. So it's going to be cosine of 5 pi 18. Okay, plus I sine of 11, sorry, 5. 5 pi 18. Okay, so the angle for the top is 11 pi 18, and the angle for the bottom one is 5 pi 18. Okay, you know that we simplify the number outside. This is nice. We can simplify it. So that gives us a 2. And for the CIS, we just subtract the angles. So it's going to be equal to, the number part is 2. If you cannot simplify it, you write it as a fraction, as a ratio. Okay, in this case, it is 2. Okay, it's going to be 2 times cosine 11 pi 18 minus 5 pi. You see, this is 11 pi 18 minus 5 pi 18. Okay, that's it. 11 minus 5 would be 6. So that gives 6 pi 18. You simplify it. So that gives you pi third. Okay, do the subtraction outside and bring the angle whatever you got it. Okay. So we just must know that when you divide, you subtract. So this is going to be CIS of the pi third plus I sine of the pi third. Okay, 60 degrees, and you substitute and you're done. It's going to be 2. The cosine of the 60 degrees is going to be, that's it, 1/2. And it's going to be I, the sine would be radical 3/2. You multiply the 2 inside. So make this first one 1 and the second one radical 3i. So the Z1 over Z2 as the complex numbers, 1 plus 3i. See, nice and easy procedure to get these numbers done. Okay, so that's operation with the complex numbers, but in polar form. So, just make sure you know it. The assignment, the section that you have in your book, quite a lot. You can practice a couple of them. Just make sure you are able to do it. So be careful, the angles, and at the end that we give you something that you'll be able to simplify it, okay? So at the end, it should be something familiar when we add and subtract. Okay, any question? So that is going to be, okay, that is the operations. Okay, this is going to be the operation with the polar form that we have, okay? So let's see what else. Now, that's the next one is the big one. The big one, remember, we talk about we can use the polar form to get the powers of the complex numbers, but at the same time, we can use the polar form to get the roots, the solutions of the, okay, the solution of an equation, if you like, or just the square root, the third root, the complex root, we call it. The complex root of a number, the first, the second, the third, the fourth, the fifth, etc. So we give a couple of them in different form. Okay. No, rectangular form and the standard form are going to say yes. For the complex numbers, you see, this is usually called the standard form. We give you the form A plus BI. Rectangular form, we accept this one as the case. The rectangular means you can write on as an order pair if you like. 1 and radical 3. I think your book called this one rectangular form, but I call it the standard form, A plus BI. Okay, so let's go to this one, the big one over here. You got to be patient to get the complex roots. I just repeat the formula that we need to know. So you get a couple of different form of the question on this one, a format of that you have to find it directly for us, and the form that you have to use it, just find it as an equation. So this is number 5. Okay, number 5, we are going to find complex roots. Complex okay, complex roots of numbers, if you like, roots of numbers. The numbers can be, okay, the numbers can be real number, or the numbers can be complex numbers, doesn't matter. But we are interested in complex roots. Complex root means if you would like to find the fifth root, you have to have 5 solutions. If you would like to have n root, you must have n solution for us, okay? So that's the meaning of the complex root. Just remind you the formula. This is going to be the formula for the complex root. So if a complex number is given to you, you see if this is going to be your complex numbers of the form of the R, for example, CIS of the data. If this is given to you and you would like to find the n root, okay, n root, z to the 1 over n. So the result is going to be, you are going to take the n root of R, okay, n root of R, but that CIS is going to be different. Okay, this is going to be, in fact, the CIS of, okay, the CIS of, and this is going to be data plus, okay, this is going to be the data plus 2k is just the period of the function. You know that the cosine and the sine are periodic, and the period is going to be 2 pi or 2k pi. So it's going to be 2k pi, okay, 2k pi, and divided by n. So in expanded form, z to the 1 over n is going to be r to the 1 over n. Okay, cosine, it's just another version of the De Moivre formula. So this is going to be cosine of the data plus 2k pi divided by n, okay, plus I sine of the data plus 2k pi divided by n. Okay, now you are going to get n solution. How are we going to find the n solution? You just change the k over here. So we are going to change the k into the k equal to the 0, 1, 2, up to the n minus 1. Up to the n minus 1, that gives you n solution. If you keep going, you see if you go once more, if you go to the n, the next number is n. If you put the n over here, you simplify that, take you back to the, okay, to the one of these. So that's why you have to go up to the n minus 1 in order to get n solutions, okay? And there is going to be n solution all the time, okay? That's a famous Gauss theorem that we're going to have, okay? This is going to be, what do you mean? No, this formula, you see this formula can be summarized at CIS, cosine of the data plus I sine of the data. These are just a brief format of this formula. Okay, CIS means cosine plus I sine. That's optional, okay, but we use it, but this is going to be the expanded format, okay? We talk about it, this is another notation, short notation for the, okay, the short notation for the polar form of a complex numbers. Okay, so this is our formula, that's it. So the number would be given, okay, and the roots, you are going to find it for us and simplify and list the solution, and you are done. Okay, there you are. In this problem, number 5, part 1, they ask you the 4th roots. Okay, so this is part 1. Okay, in part 1, you've been asked what is the 4th root. Okay, the 4th roots of 4 minus 4 radical 3i. That's it. So you are going to find the 4th root of this. So this is going to be your z. So you're going to find the z to the, it is going to be z, and you're going to find the z to a quarter, if you like, okay? So what you are going to do is just going to be the solution. So in this case, n is equal to 4. So you pick your z, okay? So you have the z is equal to Z is equal to the 4 minus 4 radical 3i. Okay, and you are interested in what? You are interested in Z to a quarter, the 4th root of a Z. Okay, now you know it. This is it. You have to find the R and the theta, then form your formula and list your solutions. Okay, any question? So the important part is the polar form of this number. Okay, so go for the polar form and make sure you get it right. So what we have is, this is it, 4 minus 4/3 of I, which is, I just call it X plus IY. So I can find my X and the Y. X is equal to 4. Okay, and the Y is equal to the negative 4 radical 3. So I identify the position or where the point is. X is positive, Y is negative, so the point is here, the 4th quadrant. Okay, so we go for it, we find the R. So R is equal to the X squared plus Y squared. Okay, so this is going to be, it's going to be 4 squared for the X plus negative 4 radical 3 squared for the second one. So the first one is going to be 16. The second one, 4 squared would be 16. Radical 3 squared would be 3. 3 times 16 would be, okay. So that gives you 64. I'm sorry, it's going to be 48. 48. Eventually would be 64. Okay. So we add them together and that would give us 64. 64, which is equal to the 8. Remember, R is a positive number, so it's not going to be positive negative 8. Any question? So that's the R. Now, what else? We have to find the data. So the tangent of the data, that's the important part. Okay, tangent of data is y over x. Okay, is going to be y over x, and this is it. Y is a negative 4 radical 3 over 4, so that gives us a negative radical 3. Then you have to pick the data for this one. Okay, this is it. Radical 3 usually is the tangent of the 60 degrees, but you are here. You are here, it's going to be 60 out of 360, so it's going to be 300. Okay, so the data must be 5/3. Any question? Just make sure you get the correct one. For the radical 3 by itself, radical 3 is the tangent of 60 degrees. 60 degrees, but you have to be here. So it's going to be 60 out of 300. Okay, 60 out of 300, which gives us 300s. Okay. Now we are ready to go and write the general formula. Okay, this is going to be the case. Going back, the number was 4 minus 4 radical 3i. We want to raise it 4th roots. That's the 4th roots. Okay, that give you the 4th root, and this is going to be equal to r to a quarter. What is r? R is 8. So it's going to be 8 to a quarter. Okay, times cosine of data. Your data is 5/3. Okay, 5/3 plus 2k pi. Okay, plus 2k pi over n, which is equal to 4. Okay, plus I sine of. Okay, sine of 5/3. Okay, 5/3 plus 2k pi divided by 4. divided by 4, but your k would start with the, okay, k would be equal to the 0, 1, 2, and 3. Okay, so that gives you the format of the solution. Okay, now we go back and we just get some of the solutions. Quickly we can find it. Okay, so this is going to be the journal one. Okay, these are going to be the journal one, but you should give us that 4 solutions. So if you put k equal to the 0, k equal to the 0, we usually call this one z1. Okay, this is it. It's going to be 8 to a quarter. You know, you may be able to simplify a little bit this one or just write it as is. 8 to a quarter. Okay, 8 to a quarter, and if you put k equal to the 0, this 2k pi would be 0. Then you get 5.3 divided by 4. So that make it to the cosine of 5 pi 12, if you like. Okay, that give you 5 pi 12 plus I sine of, okay, the sine of 5 by 12 again. This is going to be the case. This is going to be one of them. Okay, you know, sometimes we give you the one that we are going to give you is going to be a nice one. Then you'll be able to simplify it. But this one, they tell you that leave it in polar form. This is it. This is a polar form because you cannot simplify it. That's why they ask you to do it in the polar form only. Okay, so this is one of them that we're going to have. You can use those conjugate that we talk about it to write another one right away, and then you'll be able to just find, you see the other solution, we talk about it, it's going to be something like Z1, Z2 is going to be 8 to a quarter. And you write this one as a cosine of the 5 pi 12. Remember the conjugate minus I sine of the 5 pi 12. So you already got the 2. Okay, you just find another one, then you'll be fine. What's the question? To get these numbers, how do you know it's 5 by 12? Which one are we talking about? This one? Put k equal to the 0. If you put k equal to the 0, this would disappear. You get the 5 pi 10 divided by 4. 5 pi 10 divided by 4, then you 5 by 12. It's like dividing up 2 fractions. You write the first fraction multiplied by the reciprocal of the second one. So it's a 5 pi 3 times a quarter. So that gives you 5 by 12. Okay. And you know, it's going to be 75 degrees. So it's not going to be a nice number to substitute. That's why they ask you to leave it in the polar form. Okay, just one more would be enough. If you put the k equal to 1, and so it's going to be Z3, not bad. It's going to be 8 to a quarter. Let's see, cosine of. So if you put k equal to 1, what are you going to get over here? You have to simplify it a little bit. If you put k equal to 1, so that gives you 2 pi plus 5 pi 10. You have to find the common denominator for this. It's sometimes going to be messy, but we give you something nice, but not bad. It's a 2 pi over 4 and plus I sine of the 5 pi 3rd plus 2 pi over 4. Okay, you put the k equal to 1. You have to simplify it. The top 5 pi 3rd plus 3 pi, see 3 times 2 would be 6. That gives you 11 pi 3rd. You divide it by 4. That gives 11 pi 12. So the Z3 is going to be 8 to a quarter. Okay, and this is going to be cosine of, okay, it was 11 pi 4. 11 pi 4 plus I sine of 11 pi 12, sorry. And that gives you 11 pi, okay, 11 pi 12. So that's going to be the third one. You get the conjugate that give you that give you the fourth one. The one that would be getting more familiar is when this given number is not going to be complex numbers. But so this is going to be C3. If you consider the complex conjugate, change this positive into negative, that give you the Z4. So I write down here. So the Z4 is going to be 8. This is one of the problems in your book. 8 to a quarter, and you can write it as a cosine of 11 pi 12 minus I sine of 11 pi 12 as the final answer. So that
Okay.
give you 4 questions. Yes, for
If it's subtraction, can we still write it as CIS?
yes, all of them be right.
Okay.
Subtraction, no, you can't write that.
Only if it's addition.
Yeah, the way we do this problem really is we just stop here. You see, this is the one. They call it CIS of, you just simplify this part, you see. If you find the common denominator at the top and the bottom, then you can write it down. But I don't suggest it because it's the first course. You want to, no, not CIS. CIS can use for the passive polynomial.
Okay.
Okay, so best one. What's the question?
About Z2. Z2.
Yes?
Here, can you please explain it?
No, I said the complex solutions are coming in pairs.
Yes, but
Oh.
why here minus cosine 5 pi?
No,
12?
conjugate. This is a plus I, the conjugate would be minus. The conjugate of a complex number, you see, if you talk about conjugate, you just change the I, sign of the I. The conjugate of 1 plus I would be I, 1 minus I. It's like when you use the quadratic equations to get these numbers. Between that is going to be yes, if the number of the solutions are even. Yes, you are right. Because if we talk about it, that the solution is like, when you do quadratic formula, remember negative b plus or minus radical. So if it's going to be complex solutions, the complex solution must comes in pairs, if you like. So you have to have 2 of these. So as soon as we get one of them, then you get the complex of the other one. We have an easier one so that we can check it and show you that this is what would really happen. Let me just do one more. Okay, but you got to be patient to get through this, especially when it's a complex numbers. But when we use it, it's going to be of solving the equation. So this is going to be easier. Let me just give you one more to see what I'm talking about. You see, the part C is the type that we mostly interested in because we want to use it to solve the real equations. You see, they want to find the cube of -8. You know that if this is going to be given to you in algebra, the answer is -2. Cube root of -8 is -2. But remember, it's complex roots. When it's a complex roots, cube of -8, you must give us 3 solutions. Okay, don't say, oh, I know it. Yes, but we ask you for the cube roots of the complex numbers. So what we're going to do, we have to change it to the complex, to the polar form. So I'm going to call it z equal to the -8. So what I'm interested in is z to the 1/3. Z to the 1/3 is a complex number, so it's not going to be just a -2. I must have 3 solutions. One of the solution would be -2, but the other 2 would be complex. Now how are we going to find this one? We have to change it to the, okay, we change it into the polar form, so it's going to be -8. Okay, so we call it what? We call it x plus iy. So in this case, what's going to be x? X would be a -8, and the y would be 0. That's going to be the one. That's your question. to get these numbers. Why 1/3? Because they asked for the cube.
Mhm.
Cube root.
Huh.
Cube root. Okay, that's a cube root. I'm sorry, the root is missing here. The cube root. The cube roots of, this is it, complex solution. The cube roots of the -8. Okay, so that's why it's 1/3. So we should get 3 solutions. So let's see, where are you? -8. You see, this is going to be -8. For this one, you got to be careful. So the angle in question is, you see, this is going to be the angle in questions. So the angle in question is pi. Okay, it's going to be -8. The angle would be pi. If it's going to be +8, what's the angle? If it's going to be +8.
0 or 2 pi
No, just 0.
to 0.
Yeah, because we pick only one solution. So if it was z equal to the 8, you get the 0. But if you get the negative number, it's going to be pi. You can check it with the tangent situation, but it's going to be easier. Okay, any question? So we have to find the r. R is clear in this case. R is going to be x squared plus y squared. Okay, our x squared would be 64 and the y of 0. So radical 64, that gives us that 8 again. So r is equal to the 8. Okay, we already get the data. I can confirm it again. This is going to be tangent of the data is equal to the y over x. Okay, remember your y is 0. This is going to be 0. Okay, so yes, the tangent of the 0 is 0 and the tangent of the pi is 0. But you have to check to see where you are. You are here, so the angle must be pi. Okay, so that's very crucial one, not to miss it. So the data is equal to the pi. Okay, but so that's why the position of the position of the point is going to be important for us. Okay, this is going to be the one. What's your question? I don't know. What do you want? If it's an even root, what do you mean by an even root? You mean odd root? I don't know. What's your question? Odd root. So it's odd root. What do you want? It doesn't matter. Even odd, you are going to have same number. The odd root, it's going to be even root. No problem. It's complex numbers. It's always got the solution. You see, any number, positive, negative, doesn't matter. Any number you give me, the n root of that number, it doesn't matter. N is even or odd. I will give you n solutions. That's why we use complex numbers. Okay, so it doesn't matter. Even number, odd numbers, positive number, negative numbers. Okay, so that's it. Any question? So be very careful for, especially when it's just a number. Now we are ready to give the formula. So that's it. So we have the z, the -8. We identify this. So we go to the formula. That's the formula. The number is -8. -8 to the 1/3. Okay, remember the formula, r to the 1/3. Our r is 8. 8 to the 1/3. Those CIS that we talk about it. So it's going to be the cosine of what? Data, which is pi, plus 2k pi, divided by, this is the third root, it's going to be 3, plus I, okay, I, sine of y, again the pi plus 2k pi, it's a CIS, 2k pi divided by 3. Now the k is going to be 0, 1, and 2, because we are interested in 3 solutions. Even if you make a mistake, continue, you are not going to get anything new. Because if you go with the 3, you see, if you go with the 3, this would be 6. When you break it, would be pi third plus 6, 3. 6 over 3 would be 2. So that gives it 2 pi. And you know that in case of the cosine and the sine, you drop the 2 pi. So that's why if you repeat it, you are going to get the repeated solutions. Okay? Any question? Let's check the solutions. We need 3 solutions. K equal to the 0 first. If you put K equal to the 0, we call it Z1. It's going to be 8 to the 1/3, okay? Cosine of what? You replace K by 0, that give you cosine of the pi third only. Plus I sine of the pi third. Okay, we put the K equal to 0, this part would be 0. So the leftover is going to be pi over 3 plus pi third. Now we can simplify it. 8 to the 1/3 is cube root of 8, which is 2. Cosine of the pi third. Cosine of what? Cosine of 60 degrees, which is going to be equal to the half. Okay, and plus the sine of the pi third, which is radical 3/2. If you multiply the 2 inside, Z1 would be what? Z1 would be 1 plus I radical 3. This is one of the solution. Automatically, we can get the second one. What is the second one?
1
1 minus I radical 3.
yeah.
Because when you use complex numbers, it's always like A plus or minus. Okay? So we need one more solution. So we continue to get something else. We start with the 0, we get 2 solutions, okay? If it's complex, just switch it into the conjugate to get the other one.
Conjugate, yeah.
Okay, and then, so we continue to get another one. So K equal to 1. So what is going to be the case for the K equal to 1? K equal to 1, we already got 2 solutions, so we call it Z3. Z3, go to your formula again, you see, and you are going to substitute K equal to 1. So that gives us 8 to the 1/3. Okay, 8 to the 1/3, that gives you cosine. Okay, cosine of what? The top is a pi, the K1. So that gives you pi plus, okay, pi plus 3 pi. Oh, sorry, 2 pi, K equal to 1. Pi plus 2 pi, that's a 2. It's going to be pi plus 2 pi divided by 3 plus I sine of pi plus 2 pi divided by 3. Okay, simplify it. 8 to the 1/3 would be 2. Cosine of, what is this now? Pi and 2 pi would be 3 pi. 3 pi over 3 would be pi. Okay, pi and 2 pi, 3 pi. 3 pi divided by 3, that gives us pi. Pi plus I sine of the pi. But you know that the sine of the pi is 0. Cosine of the pi is -1. So you get what you know it, you knew it in advance. -2. So the third solution is a -2. So we stop here, we have 3 solutions. 1, 2, 3. You see, one of them is real, Z equal to -2. The other 2 are complex. So the complex must be conjugate of each other. If you continue, you see K equal to the 0, K equal to the 1. If you continue, get K equal to 2. If you go with the K equal to 2, you get this one. You see? If you don't do it, I just do it just to show you, but don't do it on the test. You are done. You see, if you do K equal to 2, what's going to be K equal to 2 in the formula? That gives you 8 to the 1/3. Okay, so it's going to be 8 to the 1/3 cosine of, you see, if you put K equal to 2, that gives you 2 times 2, 4. Pi plus Okay, that give you pi plus 4 pi over 3 plus I sine of pi plus 4 pi over 3. Okay, so you have a to the 1/3 cosine of 5 pi third plus I sine of 5 pi third. You see, where is the 5 pi third? 5 pi third is what? Is 300 degrees. So in 300 degrees, you are going in the fourth quadrant. So the cosine is the same. So the cosine is the same as the 60 degrees. Okay, which is going to be 1/2. But the sine is negative because in the fourth quadrant, the sine of the 5 pi third is going to be negative. So that gives a negative radical 3/2 of I. And if you simplify it, that gives you this one. You see, if you multiply inside, so the result is going to be 2 times. Okay, it's going to be 2 times 1/2 minus radical 3/2 I. If you multiply them together, that gives 1 minus radical 3I. And this is exactly what you already got here. See, that's why when we get the complex solution, we just predict the other solution right away. We know that the solutions are going to be conjugate of each other, if you like. They are going to be conjugate of each other, so we get the other one automatically. You see, automatically we get the other one. So we don't do this one as soon as we get the solutions. Any question? It's very nice method. I told you, if you're heading for any engineering or physics, you are going to do quite a lot of these type of ideas, because when you are in science, in the application, the domain is going to be complex numbers because you don't want to lose anything. So it's not the case that you want to solve an equation, you say there is no solution. No, since you're working with the complex numbers, all the equation can be solved. Okay, all the equation can be solved. So there is not going to be the case that you stop for it to get these numbers. Okay, any question? So that is the case for the -8. The case of the 1 is very popular. Okay, the case for the 1. So I give you one of these one as well, and a different format. This is one format of the problems. So the numbers would be given and they ask for the specific root. The other format is they write it down as an equation and they ask you to solve that equation for us. Okay, so let's take the other one. We give it 2 formats, so we want to make sure you understand the instruction of the problem. Any question? So important part is just the beginning, really. Make sure you pick the correct correct data, that angle, especially when you work with only numbers. When it's a complex numbers, automatically we get it. So I'm going to give you another one, very similar, but quite different. You see, look at this one. So this is a format of number 6. We just ask you to solve the equations for us. Okay. So in number 6, we wanted to solve each equation. Solve each equation. Remember, you are not in algebra. You are in this course. This means you can use complex numbers. Okay, solve each equation. And this is the first part is in fact this equation. Z cubed minus 8 equal to the 0. Okay, on the test we may emphasize, ask you find all the solution, complex or reals, okay? Just to make sure you are not going to do it in algebra. You see, this is going to be find all solutions, all real and complex. Real and complex solutions. Because if it's going to be in algebra, you factor it and then you are going to give us one solution. But it's not the case here. Let's see what's the difference between this problem and the other one. So what we're going to do is we are just using the those roots complex roots. I just move the 8 to the other side, so that give me z cube equal to the 8. Okay, so I want to find the z. So in order to get the z, I should find 8 to the 1/3. 8 to the 1/3 is cube root of 8. The answer is true if you are in algebra, if you don't believe in complex numbers. Okay, but what we would like to do is, from our point of view, they call it z, they didn't call it x. So this means you are in a complex mood. So from our point of view, any solution, any equation of a 3rd degree should have 3 solutions. So that's why we have to find all the solutions, okay? The complex. So from now on, it's just finding what? Finding the cube root of, the 3rd root of 8. Okay, that's going to be the one. No, it's not 2 and 2i. Okay, and you must give us 3 solutions. So what we are going to do is, you have to do it for the test. Remember, you just don't give us the solution right away. So just change it to the complex form. Okay, this is it, 8. So what's going to be the complex form of the 8? So 8 is going to be x plus iy. So your x is 8, y is 0. Then you check to see where you are. You see this point? This time you are here. Since you are here, the angle between the positive part of the x-axis and your number is 0. So you have to pick the data to be equal to the 0. Okay, in the other problem, you did have a -8. You have a -8, okay, so the angle was pi. You know that this is going to be the angle between the initial side and the terminal side. So in this case, the initial side and the terminal side coincides. So the angle is 0. Okay, so be careful to pick this one. So the r is going to be just the 8 as we did it. There's no difference between these two. Okay, the x squared plus y squared. So that would give us what? That's going to be 64 plus 0 is going to be radical 64, which is equal to the 8. So r is equal to the 8. And we already talked about the angle, so it's 0. Okay. So now we are ready to give you the cube root of 8. So this is it, the complex roots. Write the formula. Remember, it was r to the 1/8, it's going to be 8 to the 1/3. That is CIS of 0. So it's going to be what? It's going to be cosine of, remember data is 0, plus 2k pi. 2k pi is the 3rd root, and plus I sine of, data is 0, and 0 plus 2k pi over 3. Okay, and then k is going to be equal to the what? 0, 1, and 2. Okay, so basically, this is it's going to be 2k pi. So it's going to be equal to, is equal to the a to the 1/3. 1/3, you have a cosine of, you have the cosine of a 2k pi 3rd, plus I sine of, again, 2k pi 3rd. And the k is going to be equal to the 0, 1, and 2. Okay. So we are going to, this is the general solution. You have to give us those 3 solutions. So that's it. We start with the k equal to the 0 to get the z1. Okay, k equal to the 0, that 8 to the 1/3 would be 2. Okay, times, if we put k equal to the 0, that give a cosine of 0, plus I sine of 0. Okay, we know that the sine of the 0 is 0, and the cosine of 0 is 1. So that gives us the solution that we knew it. Okay, we know that one of the solution must be equal to 2, so we need 2 more. Any question? So you continue to get it. This is a real solution. If it was a complex solution, you are going to have a second one automatically. It's a real. So you have to find the second one. So you start with you continue with the k equal to 1. Okay, k equal to 1, so the z2 is going to be equal to, this is already 2 times k equal to 1. So we put k equal to 1, that give you what? That give you the cosine of, okay, that give you the cosine of the 2 pi third, okay, plus I sine of 2 pi third. Okay, so we replace the k by 1 in the formula, so that give you cosine of the 2 pi third plus I sine of 2 pi third. So the 2 pi third would be what? 120 degrees. So it's in the second quadrant. It's like 60, but different signs. Okay, the 2 pi third, the cosine is negative, so that give you negative half. Okay, negative half, and it's going to be plus I radical 3 over 2. Okay, so we multiply the 2 inside. So the z2 is going to be negative 1 plus I radical 3. So this is going to be the second solution. Any question? Now we can find the third one right away. What's the third one?
-1 minus I rad 3.
That's it, negative y I rad 3. Because you know that since the second one is a complex number, so the third one must be conjugate of this one conjugate. You just change the sign of the I here. Okay, it's a positive, make it to the negative. So and that's it. You see the cube root of 8 in this case, you get three numbers. 2 negative 1 plus I radical 3 and negative 1 minus I radical 3. That gives us three solutions. See the negative 8 that we did was a little bit similar to this one. So the 8 and the cube root is very popular because, you know, but again, if you are in algebra, you say, oh, z equal to 2, you just take the cube root because you don't believe in complex numbers over there. But with this method, that's it. There is no equation without any solution. It's a great theorem that it was proved by Gauss. He just introduced this type of ideas and he showed that any equation of n degree would have n solutions. Of course, some of the solutions are going to be complex numbers. This theorem is so important. They call it the fundamental theorem of algebra. The fundamental theorem of algebra will tell you that any equation of n degree would have n solutions. And over the years, you know, if you want to be famous, you try to prove this theorem. We have 3 branches of mathematics. We call it algebra, abstract algebra, of course, analysis, and the other one is called topology. It's like geometry. This theorem is such an important piece that you can prove it in all these 3 branches of mathematics. They seem to be different branches, but they connect this problem and prove it. And there is a book written by an Australian mathematician. In that book, if you search it on library, if you're going to be at the university, you see it right away. In that book, there are something like 35 different proofs of the fact that any equation of n degree would have n solutions. So it's just a piece of history, really, this type of operation that we do. Of course, that theorem is a little bit more complicated because the equation that we give is easy. Z cubed minus 8 equal to 0. So you can give me some equation like z cubed plus 5z squared minus 3z plus 1 equal to 0. You may give me that equation, but I can prove that equation would have also 3 solutions. But you know, you need a little bit more to be able to do it. So I just want to make sure that you know how important it is going to be really to take care of this, you know, this concept, and you're going to use it in future quite a lot. Okay, I'll give you a short break. We come back, we can do one more of these. I do the one, and then I need to give you some of this equation. I need to review that one too. Question number 1. Okay, so we give you 2 questions on the complex roots. Okay, we try to give you something nice. But the important part is just to be aware of the, of how we're going to apply it. This is one of the conclusion of this course. Okay, you got 10 minutes. We come back and we take care of the rest. Okay, see you then. Okay, let's do going to do one more for you if you like. This is in application problems, we have something we call it roots of unity. For number 1 is also important. So this is number 6, part 1. I do the part 2 as well. And try to give you now, we want to just make sure you know it in future. If you if you face this type of problems, depend on your discipline, then you know what's going on. You can go back, and check the formula. It depends what you are going to do in future. Okay, that's the purpose. We are not going to make it difficult. Okay, so this is the second part. And they ask you to solve this equation. Solve z to the 4th plus 1 equal to the 0. In the application problems, we call it root of unity. Z to the 5th, to the 6th, to the 10th. These are important, okay? In calculus, in algebra, z to the 4th minus 1 equal to the 0. You did have this type of problems quite a lot. You see, if you given x to the 4th minus 1, you factor it. You know that x squared minus 1 times x squared plus 1, then x squared minus 1 can also be factored. But when it's a positive, we usually say in algebra is non-factorable. And then we say there is no solution, okay, if it's going to be in algebra. But not now. We can find the solution, and there are going to be 4 solutions. Okay, so the solution of the problem is going to be this is z to the 4th plus 1 equal to the 0. You move it to the other side. Okay, then you take the 4th root. So z is equal to -1 to a quarter. Okay, so now you realize that you are going to have 4 solutions, but your solution are going to be what? Are going to be 4th root of a -1. So now we start writing down -1 as a complex numbers, and you take care of it. Okay, any question? So this is, you see, this is the even root. It doesn't matter. Yes, if it was in algebra, we say, oh, the even root of a negative number, never. But we are in a complex mood. So we know that there are 4 solutions, and we take care of it, okay? So we start with the -1, change it to the complex form. It's a -1, which is going to be x plus iy. So your x is going to be a -1, and the y is equal to the 0. Okay, so this is going to be xy plane. You identify where you are. This is going to be a -1. So you see the angle is going to be pi. If it was +1, again, the angle would be 0. You will get it with your formula, but we want to make sure that you guarantee that there is a solution, okay? So again, you are going to find your r. R would be x squared plus y squared. Your x is a -1, you square it, that give a +1, and your y is 0, so that give a radical 1, which is equal to 1. Okay, so we get the r, which is going to be equal to 1. Okay, so that is going to be r. Then we already talked about data. Your data is going to be equal to the pi. If you don't believe it, you can write tangent of the data, but it's going to be the same thing. Okay, and now we are ready. So the -1 can be written as, okay, the r is equal to the 1 CIS. We don't need the CIS for this one because we go with the -1 to a quarter, okay? So it's going to be -1 to a quarter. I remind you the formula again, then I substitute. It's going to be r to a quarter. Okay, it's going to be cosine of theta plus 2k pi divided by n, which is equal to 4, plus I sine of, we have the data plus 2k pi divided by 4. Okay, this is your formula. Now you substitute your R is equal to 1. So it's going to be 1 to a quarter, which is going to be 1. And this is going to be the CIS, or the cosine of the data equal to the pi. So pi plus 2k pi divided by 4. And this is going to be I sine of the pi plus 2k pi divided by 4. Okay. And 1 to a quarter would be just 1. And so, and your k is going to be equal to the 0, 1, 2, and 3. You need 4 solution. Okay, 4 solution, and you will get it. Okay, any question? Now you have to give us those solutions. So we start with the k equal to the 0. We substitute. Let's give us the first solution that we call it Z1. 1 to a quarter is just 1, so we have to check this one only. So this is going to be the cosine. Put the k equal to the 0, so that give a cosine of the pi 4. Okay, plus I sine of the pi 4.
Professor, don't you need the
Yes.
one outside the parentheses? 1 to a quarter.
No, I just skip it. One.
Oh.
One. We
Oh,
just,
okay, yeah.
So we just, take care of that one. So this is going to be the case. Okay. Pi 4 is a familiar one, so we substitute. That 45 degrees. So the first solution is going to be, it's going to be radical 2 over 2, 45, plus I radical 2 over 2. Some people factor it out, but you don't have to. So this is going to be the first solution. Okay, any question? Automatically you get the second one, because this is a complex numbers, and the second one automatically is going to be the conjugate. So the conjugate would be radical 2 over 2 minus I radical 2 over 2. So this is going to be the second solution. Okay, any question? We need 2 more. So we continue. That was k equal to the 0. You put the k equal to 1 to get the third one, and automatically you can get the fourth one. Okay, so we take the k is equal to 1. K equal to 1, so we are going to call it Z3. Z3, you put the k equal to 1 here. So that gives you Z3 equal to the cosine of. I rewrite it so that you know the origin of the argument. So this is going to be the 2 pi, and this is going to be the 4, and you get a plus I sine of, okay, pi plus 2 pi over 4. Okay, so that gives you sine of this gives you the cosine of the 3 pi 4, 135 degrees, plus I sine of the 3 pi 4. 3 pi 4, 135 degrees in the second quadrant is like the 45, but the cosine is negative. So it's going to be equal to the negative radical 2 over 2, okay, plus I radical 2 over 2. So that gives you the third solution. It's a complex numbers, so automatically you get the fourth solution. So what's going to be the fourth one? The fourth one is a conjugate of this one. You just change the sign of the I. So that gives you negative radical 2 over 2. Okay, negative radical 2 over 2 minus I radical 2 over 2 as your 4 solutions. You see, nice 4 solution. 1, 2, 3, 4. Okay, and all of them are complex solutions because there is no real solution for this problem. That's why when it's in algebra, we say, oh, there is no real solution. In algebra, we say it's non-factorable. It says a non-factorable and there is no solution. But over here, you see, we can give you 4 solutions. Okay, any question? So this is how we handle these type of problems. As I told you, this is just the fourth. There are a couple of theorems, if you there are various identities among these solutions that they usually like it, but they give you one. So it's going to be in this form. One of them is going to be in this form. Just solving the equations, one of these powers, that's 4. Nice. We may give you 6, 8. Okay, the third, the fourth, just be able to write it down, and this is going to be the final answer. It's going to be something nice, you know, you take care of it, and that gives us the numbers. Any question? So that's the roots of the complex numbers. Number 7 is the same one. We just repeat it. These are from various tests that we are going to have. Okay, that was number 7. Number 8 is the power of a complex numbers. Again, I do a couple of these two, and then I go to the equation. So I just put all the problems that I have before, and I post a take-home one for you. We need a take-home one for this one, so that you take care of that take-home one and get extra point, 2 points, and then it would be good for the for the final. So because all these, you know, these tests would be all repeated on the final again. Okay, so again, this number 8 is just the power of the complex numbers. We did one, so I do one more here. They ask you to simplify and express the result. Okay, this is like the one on the second one. Simplify and express your answer, your result in the standard form. Okay, your answers. This is going to be the case in the form of in A plus BI form. We call it the standard form. Okay, so I'm going to do part B for you because of that power that we have. Is the 1 plus I to the 20. You see, you want to find this power. Again, this is easier. You know that we changed the 1 plus I into the polar form, and we raise it to 20 and just using the Moore formula. So that's it. You get only one solution, and that's an easy case. Okay, so change it. So we are going to call it Z equal to the 1 plus I. So we are interested in Z20. It's not the root, it's just the power. So we need to change this one into the polar form. So we start with the 1 plus I is equal to the X plus IY. So your X is equal to 1. And your Y coefficient of the I is also equal to the 1. You identify where are you. X and the positive, Y are positive, you are here. The first quadrant, so that's easy. That's it. We check the R. R is going to be X squared plus Y squared, which is going to be radical 1 plus 1, which is a radical 2. So R is equal to radical 2. Okay. R is going to be equal to the radical 2. We have to find the data. The tangent of the data is going to be y over x. Okay, y over x, and over here is going to be 1, 1, which is equal to 1. You want to identify the data. The data is in the first quadrant. Since it's in the first quadrant, so your data is going to be pi 4 only. Okay, you know that. You may get a positive number, but you are going to be here. So just make sure to pick the correct one. Okay, now we are ready. So we get the Z, so 1 plus I. So 1 plus I is going to be R CIS, is going to be radical 2. Radical 2 cosine of the pi 4. Cosine of the pi 4 plus I sine of the pi 4. Okay, this is going to be our complex numbers. Now you want to raise it to 20. So raise both sides to 20. So it's going to be 1 plus I, raise it to 20. It's going to be raise this one to the 20, radical 2 to the 20, and then cosine of the pi 4 plus I sine of the pi 4, raise this one to 20. Okay, that's going to be the case. Any question? So I did it separately. This is it. This is radical 2 to 20. And this is going to be this part over here to the 20. Okay, so that's it. We simplify it. It's going to be 1 plus I to 20. Radical 2 to 20 is like 2 to the 5th, because this is 2 to the, okay, 2 to the 1/2 to the 10. So that gives you 2 to the 5th. Radical 2, just divide by 2 if you like. And for the demois, you bring the 20 down. So it's going to be cosine of 20 pi 4 plus I sine of 20 pi 4. Okay, that is going to be the case. Now we continue. 2 to the 5th would be 32. And over here, you simplify it. Okay, you simplify by, this is it, give you 5 pi. 5 pi plus I sine of the 5 pi. Okay, the 5 pi, you can throw out the 2 pi, throw out the 4 pi. It's a 4 pi plus pi. This is 4 pi plus pi, because you know that the sign is periodic. And this is the number of the time you go around the circle. So it's going to be like the cosine of the pi plus I sine of the pi. Okay, the sine of the pi is going to be equal to the 0, and the cosine of the pi is -1. So the result is going to be 32 times -1, which is -32. Nice. You see, 1 plus I raised it to 20 is going to be equal to the -32, and beyond that. Okay, so, you know, the power of the complex numbers are shorter, okay, you know, to find, but be careful, make sure you pick the correct data. So all of them are depends on the, okay, are depend on this angle that we usually, you know, we usually pick to get those numbers.
Professor, I have a question.
Yes.
How come the rad 2 was raised to 10, not 20?
You see, the rad 2 is going to be, radical 2 is like 2 to the half.
Oh, okay.
Okay, then you raise both sides to the 10. It's going to be 2 to the half, then to the 10. You know that you, when you get a multiple exponent, you multiply together. So
Okay.
it's going to be 2 to the 10 half, if you like, which is 2 to the 5th.
All right.
Okay, that's going to be 1 onion, you know, break it, you know, radical 2 squared is 2. That's another way to do it. Another way to do it, you see, this is another way to do it, is a radical 2 to the 10. It's the same as the radical 2 squared, then to the 5th. Because 5 times 2 would be 10. Radical 2 squared is 2. 2 to the 5th, 32. That's easier. Okay, when you have a multiple powers, you multiply them together. So you break the 10 into the 2 and the 5. You square it first, then you raise it to the 5th. When you square it, that gives you 2, but 2 to the 5th, 32. That's another way, you know, we do it. When it's a radical, you just you take the portion of the 10 to be able to simplify the radical first. So the portion of the 10 that you need is 2. So it's going to be now 2 squared, then 5. Okay, any question? Now, getting back to the equations again, I list some of them again for you. These are a special one, if you like. We go back to the number 1. And the one that you do, all of them are nice. I mean, when you want to find the sine, cosine, those angles, You get it from the chart. But sometimes in application case, it's not the case. You may use your calculator. So I just put a couple of them, a collection, so that when you see on the test, some of them you may have to use your calculator, at least one. You just want to make sure you are ready for it. Okay, so any question? So those equations, you did have 4, I think, on your quiz, and we are going to give you 4 again. So these are the new candidates. This is question number 1. Okay, there are all sort of equation that we need to know. So this is just to reviewing your quiz. So review that quiz too. So nice problems, but these are going to be, that give you a hint, the type that we are going to be interested in. Okay, so this is number 1. Number 1, they ask you solve each trigonometric equation. You say solve the equation, solve the equations. Okay, they say solve the equation exactly. Exactly means don't use your calculator and just get those numbers from the chart. Of course, they say if possible. If we add this expression, this means it may not be possible to give you the exact. So say if possible. Otherwise, we ask you to use your calculator. Okay, use a calculator. So you will see this expression on the test. So let's see what does it mean. Okay, are you ready? Part 1. The part 1 is a standard one, 2 sine x plus radical 3. Okay, radical 3 equal to the 0. And the interval is 0 and 2 pi. Okay, you know that this equation is a sine equation. So solve for sine first, carefully. Okay, this is going to be the case to solve for sine first solution. You know that you move the radical 3 to the other side. And this is going to be like the one on the test, the quiz. You get negative radical 3 over 2. Again, carefully pick your solutions. You know that you go to your table, to your chart. The sign is negative. So you must be here, sign negative. So you are either here or here. This is how we're going to pick those solutions. You can check the table, you will see it, but if you want to do it, this is it, radical. You know that the radical 3/2 that we are going to have is going to be for, okay, it's going to be for sine, for the, sorry.
1/3.
It's going to be for 60 degrees, yes, for the pi third. Then we need to have it over here. So we have to add it to get this number. It's a 60 degrees, yes? It's a 60 degrees, so we have to get it in these two parts. So 60 plus 180, this is going to be 240. It's like the one on the test. I think it's going to be 2. Okay, we get a 4 pi third. 4 pi third, or over here, you have to get it for the 300ths. And the 300 is going to be 5 pi third. Okay, so this is going to be the situation that we're going to have. You can check it with your table. Okay, this is it. The sign is going to be the second quadrant that we're going to have. So this is going to be radical 3/2. If you go here, you see, if you get over here, this is a negative radical 3/2 that we have for the 4 pi third, 240. We need one here. And if you check the one over here, is going to be negative radical 3/2, which is 5 pi third. Okay, so if you identify the location that you need, So quickly you can go to the table and get it so that you're not going to you're not going to miss it. Okay. So this is it, solution 4 pi third and 5 pi third. So that was something standard, but we have to solve for sine x. Any question? That's type 1, so we give you 1. So type 2, I just repeat this problem because you made a mistake on the test. So I make it better. Radical 3 tangent of the 2x minus 1 is equal to the 0. Okay, and the x is between 0 and pi. That was the tangent square that you did have on the test. Okay, I just changed it to the tangent of the 2x only to get that 2x again. So what you are going to do, you have to solve for the tangent. So that gives you radical 3 tan of the 2x is equal to 1. So the tan of the 2x is equal to the 1 over radical 3. You have to rationalize the denominator. Multiply the top and the bottom by radical 3. So to make it into, okay, so this is what you do. So that gives you radical 3 over 3. Okay, so you have to check the tangent of the 2x to be equal to the radical 3 over 3. Any question? Now, radical 3 over 3 is going to be the tangent of the, okay, it's the tangent of the 30 degrees. Okay, it's going to be pi 6, 30 degrees, but this is a 2x. So what you have is, this is it, one solution is going to be 2x equal to, because this is the tangent and the tangent are going to be positive there. You see, this is it. The tangent is going to be positive here, and it's going to be positive here. So when you are here, this is going to be the pi 6. And where you are here, this is going to be 30 degrees and 180. This is going to be 210, 7 by 6. It's a 2x. Okay, so what we have, we get the 2x equal to the pi 6, one case, and the 2x equal to the 7 by 6. But these are 2x. You want to find the x, you have to divide it by 2. So one solution would be pi 12, and the other solution would be 7 pi 12. So these are going to be now the solution that we're going to accept. Pi 12 and x equal to the 7 pi 12. Just remind you that the tangent of the 2x, just make sure you get it right to get these numbers. Okay, so this is going to be a situation for the tensor. Okay, so the answer is between 0 and pi. So 7 pi 12. Seven pi 12 is between 0 and pi. What is 7 pi 12? Okay, 7 pi 12, what's pi 12? I think 512 is going to be 15. And the 15 times 7 is going to be less than 180. So it's correct. Yes, I know that you say the question is x between 0 and pi. 0 and pi. So what I have is I have x equal to the pi 12 and I have x equal to the 7 pi 12. And the 7 pi 12 is between 0 and pi. Okay, so you know, just to make sure that this is a 2x. You apply the 2x first, then we get the x. Okay, any question? So just the sine and the tangent, and so those 4. Now the quadratic one. Just give me this quadratic. Sometimes it's nice, sometimes it's not. Okay, this is like the one that you did on the test. with the cosine. It must be nice. Okay, so double check, make sure you get it right. X between 2 pi. You go with the quadratic formula, or you can factor it again if you like. Okay, but I go with the quadratic formula just to show you. The unknown is cosine. Remember, negative p would be negative 1 plus or minus the square root of b squared negative 1 squared minus 4ac 2 and the negative 1 can also be factored divided by the 2 times 2. Okay, this is one option. Now at the top, this is going to be 1 plus or minus the square root of, it's going to be 1 plus 8. Okay, this is 4. It's going to be 9. You take the square root, 1 plus or minus 3 over 4. Okay. Now we have two solutions. So I just rewrite it so that I can give you the solution. 1 plus or minus 3 over 4. So with the positive, that give 1 plus 3 over 4, that give you 4 over 4, which is 1. With the negative 1 minus 3 over 4, which is a negative 2 over 4, and this is going to be negative 1 half. Okay, so I have two solutions. Any question? That was easy. You can also factor it. You see, if you want to factor it, that give you 2 cosine x minus 1 times a cosine x. Okay. So this is going to be cosine x minus 1. This is going to be a plus 1, of course. 2 cosine x plus 1 times cosine x minus 1, and then you find the same solution. Okay. Now we have two equations to solve: cosine x equal to 1 and cosine x equal to negative 1 half. To find the solutions, I give you the solution here. Okay, cosine x equal to 1. Okay, you know that in this case, you are going to get x equal to the 0. It's going to be cosine of the 0 and the cosine of the 2 pi. They just put x less than 2 pi, so this is going to be x equal to the 0. The other one is cosine x equal to the negative half. The cosine is going to be negative into the, okay, this is it. It's going to be negative. So we're going to be either in the 2 quadrant, second one on the third one. So this is going to be, must be cosine of the 60 degrees. You see we have the negative 1 half in the second. You get the 2 pi third, 120. Okay, and over here you get 4 pi third. So it's going to be 2 pi third, 2 pi third, and the 4 pi third. So we are going to have 3 solutions: x equal to the 0. Okay, x equal to the 0, 2 pi third, and the 4 pi third is going to be solutions to your equation. Okay, so that was a nice one to be able to, to do it without have any difficulty. Okay, any question? Now, the second one is a kind of that tangent square that we did have. I just make something for the cosine squared, just to make sure that you are going to have for the different one. Are you done with this one? Okay, so let's see what is special about number 4. You may get this one with the sine, cosine, or tangent. So this is a number 4. And number 4, this is what I have, is a 4 plus 4, but cosine squared of x equal to the 6. And x is between 0 and 2 pi. You see? You see what we are going to do? We have to solve for the cosine first, because this is just a single term, cosine squared. There is nothing else. Okay, so you solve for the cosine, like the one that on the test, okay, on the quiz, we did have tangent squared. This is cosine squared. So we have to isolate the cosine squared first. Okay, so it's going to be cosine 4 cosine square equal to the 6 minus 4. Okay. So that gives us 4 cosine square of x equal to 2. We divide by 4, so that gives you cosine square of x equal to the 2/4, which is going to be 1/2. Okay, 1/2. Now you take the square root. Just be careful. You are going to taking the square root, so it's going to be positive, negative. Positive, negative radical half. So it's going to be positive, negative square root of the top, which is 1. The bottom one is a radical 2. Okay, you have to change it, rationalize it. So you multiply the top and the bottom by the radical 2 over radical 2. So that give you positive, negative. The top would be radical 2. The bottom one would be 2. So you have cosine x equal to positive, negative radical 2 over 2. So far. Any question? So it is a positive, it's a positive, negative. You have to put a positive, negative. So you're going to have two series of solutions, if you like. Okay, so it's positive, negative. So we're going to consider two cases. Cosine x equal to the radical 2 over 2 and the cosine x equal to the negative radical 2 over 2. Okay, so this is it. Cosine x equal to the radical 2 over 2. So cosine positive, cosine can be positive in the first quadrant and in the fourth. So we check it with the table. X would be 45. One solution. The other solution, you would like it to be in the fourth quadrant. So it's going to be 360 degrees minus pi 4. So it's a 2 pi minus pi 4. So it's 7 pi 4. So this is the first set of solution. Any question? So it's a positive number. It's positive number, but two solutions between 0 and 2 pi. One solution is in the first quadrant. The other solution is in the fourth. 7 pi 4 because cosine positive. Okay. So we go with the negative cosine x equal to. So the cosine x equal to the negative radical 2 over 2. This time the cosine is negative. So it can be in the second quadrant or the third. In the second one, pi 4 would be changed into the 135 degrees, which is a 3 pi 4. Okay, this is 180 minus pi 4. Then you have to go to the third. You go to the third, it's going to be pi 4 plus 180. Okay, so that gives you 5 pi 4. You know, you can check it with your table right away, or just get to know how we shifted, if you like. Any question? So this is it. This is just to remind you that you may have something with a square. You know, it can be tangent, sine, cosine, doesn't matter. Nicely, you have to solve for the unknown, whatever it is. Okay, and then take the square root. When you take the square root, you have to have to leave a positive, negative. So get two solutions. Remember, two solutions. Each solution will give you a set of the angles. Okay, and at the end, you get your final answer. Any question? So this is another format that we have to know it. Now, what's going to be the next one? The next one was a quadratic that you may have to do a little bit more to get it. Okay, so this is going to be the part E. And the part E, we have sine square of x. Okay, it's going to be sine square of x plus cosine x. Cosine x equal to the negative 1. Okay, it's equal to the negative 1, and they ask this type of question between 0 and 360 degrees. And there are 360 degrees. There is a possibility that you won't be able to, to find the exact solution. You may have to use your calculator. Let's see if it's going to be the case. Now, we have the square here, so we want to take care of by the cubic quadratic formula, but we have a cosine here. You know that we can go with the only cosine or only sine. So this is sine square. So what we're going to do is we change the sine square into the cosine. Pythagorean identity, remember, sine square is going to be equal to the 1 minus cosine square. So this is the one that we have to change it. Okay. So this is the solution. Just give you want you to have all the possibility in one setting. So we change this one. We change it to the 1 minus cosine squared. This is it. And we already got the cosine x. And we better bring this one to the left to make it to the positive one, equal to the 0. Okay, so you have to move this number to the other side all the time because you have to make it 0 to have an equation. And in this case, the sine square is going to be 1 minus cosine squared. Now simplify it, so that gives us a negative cosine squared. And this is going to be a cosine x. Now we have 1 and 1 would be 2. So that gives you 2 equal to the 0. Okay, so we end up with this equation in this time. Okay, to get this number down. If you feel comfortable, you can stay with this negative here. If you feel uncomfortable, you can multiply by -1. Okay, it doesn't matter. If you multiply everything by -1, if you like, you may change it to the cosine square minus cosine x, and that give you minus 2 equal to the 0. Okay, so that looks familiar. Okay, so you may be able to factor it, which is going to be the case. You need two numbers with a product of 2 and a difference of 1. So it's easy to factor, or quadratic formula, but this is clearly, it's given to you. So what we're going to do is, so those numbers are going to be 2 and, so it's going to be 2 and 1. So cosine x minus 2 times what? Times cosine x plus 1 equal to the 0, or quadratic formula. So this is going to be the case, because 1 times a -2, that gives us a -2 here. Okay, and if you add them together, that gives you a negative cosine here. Okay, any question? Now we let each factor to be equal to the 0 to solve it. The first factor and the second factor. Okay, so this is going to be the case. So if you let cosine x minus 2 equal to the 0, so that gives you cosine x equal to 2. Okay, and the other one, if you let cosine x plus 1 equal to the 0, then you are going to have a cosine x equal to -1. Okay, so we have two equations to solve, cosine x equal to 2 and the cosine x equal to -1. But the cosine x equal to 2, you know that the cosine and the sine, the range of the cosine and the sine are between positive and -1, because we're using the unit circle. So this is impossible. Okay, so the first one, we say the cosine x equal to 2, but 2 is bigger than 1. It's impossible. Okay, it's impossible to have an angle whose cosine is equal to 2. Okay, so we are done with the first one. So any question? So for the cosine and the sine, you cannot have any number bigger than 1. Okay, so that's done. So we go with the second one, cosine x equal to the -1. That's easy. Okay, you can go to the table, and or you know it, it's going to be the cosine. It's a pi. X equal to the pi only, that give you the cosine of the pi equal to the, so x equal to the pi only. That's going to be the only angle that give you the cosine equal to the -1. Okay, so this problem would, I just picked this one because that give you a couple of points that you have to remember. The points that it is So we have a sine and a cosine at the same time. We can't do it. We can do with one of them. So what we did have a sine square. So we change it to the 1 minus cosine square, and we end up with a cosine equation. It's quadratic. It was possible to factor it. So that's why we just check the factoring. Okay, we check the factoring, but we get another point to consider, and that was the fact that the cosine x happened to be equal to 2. It is impossible. You can have a cosine greater than 1 because the sine and cosine are going to be, in the unit circle. Remember, we have them in the unit circle, so it's not going to be possible. Okay, this is it. No, pi is fine. They say 180 degrees. It is between 0 and 2 pi, or between 0 and 360 degrees. Doesn't matter. Okay, so this is going to be the case. Any question? So that was another case. Now, I didn't get to the one I was talking about, but I have it. So we just work with the sine and the cosine all the time. How about this last one, which is given to you in terms of the tangent? Okay, so we want to solve this equation. 6 tan square of x, okay, plus tan x minus 2 equal to the 0, and x is going to be between 0 and 2 pi. All of them are going to be 0, 2 pi, 0 and 360. They're all the same. Now, problem is the problem of a tangent. The only thing that we can do is if you have the tangent, then we can do it. But this is a quadratic equation. You see, it's a quadratic equation with the unknown of the tangent. So what we are going to do, we are going to solve it. We're going to solve for the tangent. There is no restriction for the tangent. Tangent can be any number. Okay, so whatever you got as the solution from this equation, you can continue. Okay, so that's why the tangent is popular for applications. So let's use quadratic formula to solve it. Okay, the unknown is tangent, so I go with the tangent. So it's going to be solution. The tangent is going to be equal to quadratic formula. Negative BB is 1, coefficient of the tangent. So it's going to be negative 1 plus or minus b squared is going to be 1 squared minus 4 AC. A is a 6 and the C is a negative 2. So that gives you 6 times negative 2. Okay, b squared minus 4AC divided by 2a, which is going to be 2 times 6. Okay, it's going to be negative b. It's going to be negative b plus or minus b squared. Okay, b squared minus 4ac. Simplify the top to see if it's going to be a nice number. So it's going to be a negative 1 plus or minus. Okay, inside is going to be the square root of. Inside we get the 1. We multiply these numbers together. Okay, so that's going to be 24, 72. I think that's the case, plus 72. So I did the negative b plus or minus, that's b squared minus 4ac. That is going to be a and the c, 12, and yes, that is going, I made a mistake here. It's a 40, because this number must be nice. It's 48, sorry. Okay, 1 squared is 1, 4 times 6 would be 24. 24 times 2 would be 48. Okay, divided by 12. So that gives you 49, and then you have a nice number. So it's going to be a negative 1 plus or minus the square root of 49. 49 over 12, okay? So that gives us a negative 1 plus or minus 7 over 12. Okay, 7 over 12. So we're going to have two solutions. This is it. If you go with the positive, it's going to be -1 plus 7 over 12. So that gives you 6/12, which is a half. One solution, and the other one is going to be -1 minus 7 over 12. So that gives us a -8 over 12. And we simplify it. Okay, we simplify by 4. That gives us a -2/3. So we have two solutions over here. Okay, so you're going to have a tangent of x. Okay, the tangent of x is going to be equal to the half. Okay, and the other one is going to be the tangent of x is going to be equal to the -2/3. Okay, it's going to be -2/3. That we see both numbers are going to be unknown, if you like. These are going to be unknown, so this is where you have to use your calculator to get these numbers. The notion of the tan inverse on your calculator would give you these numbers. Remember, we did it before. It's the kind of application one that we're going to have. Okay, so this is where you get them. This is the sine, cosine, tangent. At the tan inverse, this is the one that you have to go to the second operation. This is the second operation, and I get the tangent over here. So the number that I have is 1/2. Okay, this is going to be the 1/2, and then when I operate, this is it. My calculator is in degrees, so I get something like 20. This is it. It's going to be 26.56 or 26.6 degrees. Okay, so this is going to be one of the solutions. Okay, so we're going to have x equal to 26.6 degrees. This is going to be one of the solutions. Okay. Of course, this is going to be in the range of the tan inverse, which is the -π½ and the π². That give you this one, and you can write it down in the get the the other solutions. They ask for the 0 and 2π to get the tangent. So tangent is going to be positive in the first and the third quadrant. So what you can do is you can add the pi to it to get the other solution, if you like. Okay, if you add 180, okay, so that give you the other solution, something like I'm sorry, I made a mistake here. So that was the 26.6. I add 180, so that give you something like, okay, the other one is x equal to 206.6 degrees. Okay, that's, I just want you to use your calculator. That is the purpose of this problem. So any question? We have to do the same thing for the second one. Okay, for the second one, again, we started over. It's going to be the second. Okay, that is it. It's a second. So I go with the tan inverse. This is going to be a tan inverse. This time I have a negative number, so it's going to be minus. Then I have the 2 divided by 3. Okay. So this is going to be the angle. Okay, the angle is going to be -1, -33.69, -33.7, we can call it. But since we are been between 0 and, because that gives you that -1, because the tan inverse domain is going to be between -π½ and π². Okay, to get these numbers. Okay, so that's why you get this negative number with your calculator. But we can change it into the positive format if you like. It's not going to be in the case of the tangent. They should change this domain. But anyway, we can do it. We can find the positive one first, then change it to the negative. That would be a better one if you want to use your calculator, because the calculator will give you, you know, that they give you the tangent inverse. So the tangent inverse is always between, okay, this is it. The tangent inverse is always give you the first quadrant or the third one. So the one that you got is here. You see, the one that you got is going to be negative 33. Okay, 33.69. So that give you this one. So this would be the same as this part over here, if you like. Okay. So you can add the pi if you like to get that number. I think it's going to be the case. It's a problem from your book. I just want you to know it. Okay. So the number that I'm going to pick for this one is going to be plus 180. So it's going to be 146 if you like. So x is equal to the 146. That give you, okay, that give you the other solution. If we give you this type of things, we give you something which is going to be straightforward. But that's the purpose, just to learn how you handle it if it is going to be, you know, in application problems. So you do something in physics, chemistry, engineering, then you will end up with this type of problems. But you have to make sure that you are going to be in the proper domain to get these type of numbers. So it's just for your information to see. There are a couple of them in your book, and if you want to do your assignment, so you may have to. They give a tangent because tangent is free. You can have any number you like. You cannot have the sine and the cosine, because in that case we have the restriction between -1 and 1. Okay, so if we give you one, it's going to be, you know, something nice that you'll be able to find it. Okay, so that's it. This is solving the equations. So the one on your quiz is good one. We have a similar one on the practice quiz number 3, if you want to get more practice. But the type that we are going to be interested in is going to be a type of this, the first group. Okay, question number 1 to get these numbers. And that's it. Any question? Any more you want me to do for anything from your previous quiz? I will post a take-home one for you. Okay, it's going to have 11 questions. Okay, and once you see those 11 topics on the test. So my suggestion is do these problems that I did tonight first. Okay, and then when you feel comfortable, then you just go for, okay, you go for that group if you like to get those numbers. So I give you everything, okay, everything you need, these type of the equations. Okay, the rest are going to be just the one that we did all together. Okay, there is I can do one more of those roots if you like for you. The root with let's see what we have. These are the polar form. I did the -8 for you. I can do one more. I just make one. These roots of the unity, but a couple of them. So one in your book. Just so 11 questions, as I told you, even if you already got nice points, because we drop one test and one quiz, but since these questions are going to be given to you on the final, so it's good practice really. Just practice now and then be ready for the because in a couple of weeks we are going to give you all of these on the final. So the one that is one equation, if you give me a couple of minutes, then I can do that one for you too. As I told you, I'm going to give you a couple of sections. We have two famous formulas in trig. We call it the sine function, sine equation, and the cosine equation. That's going to be useful. So we end up with that one. Okay, I'll give you one more of those roots of unity.
Can you please, yes, about the root?
Which one?
No,
Yes.
teacher, on question 8, number B.
Question 8, number B.
Number B. You yes,
That
you wrote yes, you wrote root 2 power 10. Why not power 20?
Oh, that was the one that I explained. Okay, I explained it again. You see, that was the one. Root
Yes.
2. You see, because R was radical 2, okay?
Yes.
So I want to find what is radical 2 to the 20.
Yes.
Oh, you mean I write 10?
Yes, you wrote it 10, not a 20.
Right. Okay, so you have to change that number. If it's going to be 20, you just take out the 2 first.
Mm-hmm.
You see, this is going to be the way we write it down. It's going to be a square, then to the 20, then to the 10. Okay? So radical 2 squared would be 2. So that gives you 2 to the 10.
Oh.
Okay, what's 2 to the 10? You have to find it yourself. It's going to be.
Yes, yes, yes.
See? Oh, this is the one you mean. This is
Yes.
it?
Yes, yes, here, yes.
Oh, yeah, that's
Yes.
one. Okay, so this is what it is. It's going to be 2 to the 20. 20, then it's going to be 2 to the 10. 2 to the 10 would be 32 times 32. Okay, it's 32 times 32, which is going to be, yes, it's 1024. Because 2 to the 10, you know that 2 to the 10
Yes.
is going to be 2 to the 5th times 2 to the 5th, which is going to be 1024. 1024. And this would be 1024. So everything would be 1024. Thank you.
Yes.
So the final answer is 1 plus I to the 20 is going to be 1024. Thank you.
Yes.
Negative, of course, negative.
Yes.
Negative. Yeah, thank you.
Yes.
I was just thinking about that radical 2 because I want to get rid of that one, but I made a mistake. Okay, but you know that the radical 2 to the 20, we write down the radical 2 squared first. Radical 2 squared would be 2, then 2 to the 10. Yes. 2 to the 10 to get that number stuff. Okay?
Yes.
Any question? Let me just do one more. This is just a little bit more. However, is going to, this is one of the problems in your book. You have a couple of them. So they ask you to solve this equation. They ask for the x to the 6 minus 1 equal to the 0. You see that's 1. Of course, in a complex case, because if it was in algebra, you break it into the x cubed minus 1 times the x cubed plus 1. But with that, you should have 6 solutions. If you do the factoring that you know it, you are going to get only 2 solutions, okay? So this is the way we are going to do it. I'm going to call it Z, so because I'm going to use this. So I use the Z so that I know that you know that you have to find 6 solutions. Okay, so this is it. It's going to be Z to the 6 is equal to 1. So Z would be 1 to 1/6. Since I write z, you cannot write 1, you cannot write equal to 1. Okay, because if you write 1, means you just consider to be real number. Okay, it's a complex numbers. Okay, since it's a complex numbers, it's not the case. 1 to the 1/6 would have 6 solutions. One of the solution would be 1. Okay, so be careful. So what we're going to do, we are going to change this one into the polar form. So we have a number 1. So 1 is equal to x plus iy. So x is 1, y is 0. And where are you? We are here. So what's going to be data? The angle?
0.
0. It's going to be 0. Okay, it's going to be 0 because the angle between the initial side and the terminal side of the number is 0. So that's it. So we are ready. We have to find the r. R is x squared plus y squared. You say it's going to be 1 plus 0 radical 1 equal to 1. So r is equal to 1 and the data is equal to the 0. We are ready to give you 1 to the 6. So 1 to the 1/6 is equal to what? Is equal to the, I write the formula for you, it's going to be r to the 1/6 CIS cosine of the data plus 2k pi, this time over 6, plus I sine of the data plus 2k pi over 6. Now my r is equal to 1. So it's a real number. Now I can replace it by 1 in a minute. Okay, that's going to be the cosine. The data is 0. So I get only what? I get only 2k pi over 6 plus I, the sine of 2k pi over 6. Okay, because the data, remember the data is equal to the 0. So I can simplify that a little bit. 1 to the 1/6 in this side is going to be 1. Okay, and this is going to be the cosine of what? I simplify it by 2, that give me k pi third plus I sine of the k pi third. Okay, so, but I need 6 solutions. 0, 1, 2, 3, 4, 5 to get the 6 solution. Okay, any question? So now you have to list solutions. Okay, you need a couple of them so that you'll be able to use the complex ones. So start with the k equal to the 0 to get the first one, z1. If you put the k equal to the 0, that give you cosine of the 0 plus I sine of the 0. You know that the sine of the 0 is 0. The cosine of 0 is 1, so that give you 1. And this is the one that you know. Okay? It's a real number, so you don't have any other conjugate. So you have to continue to get the second one. K equal to 1. You go with the z2. K equal to 1. That give you cosine of the pi third plus I sine of the pi third. Okay, the cosine of the pi third is 1/2, and the I radical 3/2. This is the second one. Quickly, you can get the conjugate, the free one. So the free one is going to be your conjugate, which is going to be 1/2 minus I radical 3/2. So that's a 1, 2, 3. You need to continue. You need 3 more. K equal to 2. So what are we going to get? You get a z4 equal to k equal to 2. You put over here, you see. That gives you cosine of 2 pi third. Cosine of 2 pi third plus I sine of 2 pi third. Okay, 2 pi third, 120. So the cosine is negative, they give you negative 1/2 plus I radical 3/2. That's a 4. You get a free one, the conjugate. Okay, that's a radical 3. Okay, the fifth one is free. The conjugate is going to be negative 1/2 minus I radical 3/2. This is the fifth one, but you're not done because we need one more. 1, 2, 3, 4, 5. So we have to go on. This is k equal to 2, put k equal to 3. Okay, k equal to 3. K equal to 3 here. Okay, so what's going to be the C6 is equal to the cosine of. If you put k equal to 3, that gives you 3 pi third. 3 and 3 would simplify. Okay, so that gives you cosine of the pi plus I sine of the pi. Sine of the pi is 0. Cosine of the pi is a negative 1. So C6, negative 1. Nice, you see? 6 solutions for this equation. If you're going to be in algebra and you factor it twice, you get only 2 solutions. You get only 1 and negative 1 when you are in algebra. Because you factor it into, you see, this is what you do in algebra. You factor it into the x cubed minus 1 times x cubed plus 1. So we get z equal to the 1 and negative 1, your solution. But when we say complex, it's x to the 6, so we must have 6 solutions. And this is how we do it. You see? Nice method. It's a very nice one. That's it. Any question? So a study that, the one that we did tonight, very nice problems. And be ready. We are supposed to take up one for you and we give you the test. That's going to be your last test before the final. And 2 more section I cover from chapter, I think chapter 8. Law of the sine and the law of a cosine, in order to be able to solve, the triangle problems. And there are 3 cases for the triangle that we're going to use that formula, and then we are done, right on that. Okay, that's it. I post your grade for the quiz. If you, a couple of you email it, so I will check the emails and then I give you your point. Okay, then if you don't see it, then you can email me, then I'll check it for you. Okay, that's it.
Mm-hmm. Thank you.
Okay, have a good one.
Thank you, teacher.
Okay, I'll check the homework grade, etc. I don't have, I do the test and I do the test and quizzes first, then I'll get back to those eventually. Okay, that's one. Okay, that's it. Any question, anything, just email me, just take on one, I'll post it in a couple of days times, and then we give you the test and everything. Okay, take care.
Thank
Have a good
you.
one. Bye-bye.
Bye.